Hey there, this is Ludwig from Phasio, and in this video we're going to take a look at resin printing and the pricing formula example for the same. So let's start with some key considerations. So in that algorithm we take a model and we're looking at the longest side of the model and then dividing it by a certain layer thickness. And the layer thickness division, that gives us the number of layers. So you see the layers in blue here, and they have a certain layer thickness, and there's a total height. And dividing these two gives us a number of layers. And if we multiply this number of layers with a time in seconds per layer, then the result of that is actually going to be time in seconds. And then with the print cost time, like cost per time, then we get to a cost for the unit price. So let's take a look how this can be represented within Phasio. So I'll create the SLA in this case, then I'll do print time, create the process, we'll mark it as internal, and I do this marking as internal only because I don't want customers to see this, right? If this is live already, then I hit create equation and we'll copy in the equation for my SLA algorithm. And you'll see that this will be red underlined because we didn't define these material variables yet. So let's go ahead and do that. These are just two of them. First the resin cost per liter, and then the machine cost per hour. While we're here, we can also create a material. For example, we call this just resin and define the resin cost per liter be 20 euros and the machine cost per hour be 4 euros. And just add here. Then I'll take my code and paste this into the equation. And now you see that these two material variables are actually present and can be used within the equation. Okay, so let's take a look at how this function works. There are a couple helper functions that we need, for example, support volume estimation, and that is something that there are multiple different ways to do that, of course, right? But you can first make use of the convex hull volume minus the volume here, and then of that 10%. You can also work with AI, for example, to find other ways that work perhaps a little bit better for you, if that might be the case. So when we calculate the price in the main calculation down here, we see that we first calculate the material cost based on support volume and waste volume. So waste volume is when you take your part out of the resin, there's always, like on the outside, there's still a bit of resin, right? And if we do control click, we find that the waste volume here is an estimation in cubic millimeters, area times 0.05, and that is then actually used in the material cost. And the material cost function above here takes these two volumes and the cost per liter, and then it is the total volume in liters times the resin cost per liter to put the cost out there. The next time would be print time. So this estimates the print time in seconds divided by 3,600 to get to hours. So let's go to print time, and you have the layer height here of 0.06, and you have the time per layer within this variable, right? So we will be able to understand how the print time changes when we actually change the time per layer. Then down here, we have the maximum dimension between width, height, and length. And then we calculate the angle of 45 degrees of that maximum dimension in case you print your models always at an angle. And then it's relatively simple. The number of layers is just the ceiling. So it's always rounding up between the height and the layer height. And this results in the number of layers times the time per layer, which would then result in seconds. And with that, we have our print time, and the print time cost will be the hours that we have here times the machine cost, and then the print time cost is used for the base cost, which is material cost, of course, plus the print time cost, and that then has a quantity discount applied on the base cost, and the quantity discount is up here and is relatively simple. So when anything below 5 is there's no discount, and then parts between 5 and 9 actually, right, have 5% discount, or from 10 onwards you get 10% discount, and so on and so forth. And then it's in the final unit price as well in a variable so that we are able to override the value. And that is what we're going to do now. We're going to try. Just put V1 in here, hit save, mark this equation as live, and then go create a new quote. And I'll take these two parts, and we'll select SLA, print time, resin, and we'll apply that to all parts. And I see the price is of course very different because the size is also very different. If I click on the modify pricing, I see the print time is set to be 5.6 hours and the time per layer is 25 seconds. So if I reduce that to 20, you see immediately how the print time updates and hence also the price updates, right? Say we got a really fast printer, right? Just 10 seconds per layer. So that's at 2.24 right there. And just as a side note here, this is now an even print time per layer, right? What you could also do to make your algorithm more complex, and this algorithm is just a start, you could think about the varying the time per layer based on the aspect ratio, for example. That is something where like the laser in an SLA machine takes more time to cure the resin everywhere. And like in a DLP machine, of course, that's different because it is just projecting the light from the bottom evenly. However, you can definitely think about making this instead of a constant into like a varying number, varying time per layer. And there are key considerations also with types of models where you could make use of complexity and just develop this algorithm a lot further. You can also ask the help of AI, of course, for that to cast this into an even more interesting algorithm. And if you have any questions about that, feel free to reach out. And thank you for your time.